Hi everyone. In this video, I will demonstrate to you a small tool for malware analysis that I have created. Um, it's getting as an input a file or a folder, and it's analyzing and checking whether the file in question is malicious. It's a C# tool, so I will walk you through the code to check the idea behind it and the logic that I have implemented. Alright, so just as a beginning, we can here see the structure of this solution, this project. So we have the main, our main code in the program.cs, it's a C# code. And we have here our Yara rules. I will talk about this later. We have our config file here that we will read some config inputs. Okay, so let's start with the main function here. So as you can see, the first function is to set a global exception handler. So here, if we go to the code, what it's doing is it's catching every and each exception that it's not handled in somewhere else in the code. So this is for sake of fault tolerance, and it's showing basically after this, it's just showing in the console that there was an issue. Alright, so we have here our few instructions to see if the inputs are fine, that we expect here 2 inputs. Otherwise, we will just show a help and we will return, so we will exit. Here we are getting our 2 inputs. So as I said, so the first input has to be if it's a file, so -f and the file in question, or if it's a folder, so it's -d, and the second parameter should be the folder in question. Okay, so if we go through the code, here we have our read config, which is reading the configuration of this solution, and then mainly here we are getting from this app.config, we are getting our Yara rules path, so these rules here, and we will have also our Yara exe path, so it's here in the bin folder. Okay, this one. And also we are getting the path for the quarantine. Okay, so the user here, the end user, can change all this by changing the config file. Alright, so if we go back to our main function here, we are writing that the scanning has started, and we have here a logic if it's a folder or if it's a file. So if it's a folder, we check if this folder exists. If it does exist, so we go and we walk through all these files and we analyze them. So we execute in the end of the day 2 functions, so start Yara exe and post scan. Okay, and we have the same for when the input is a file, not a folder, so we have the same here. We show the file in question and we just invoke the 2 functions. So let's see the functions now. So the first function, start Yara exe, so it's getting the file name, so the file path, and what we are doing here basically is we are starting a new process, and the process basically will open the command line, the Windows command line, cmd, and will execute this command here. So what it is doing actually, it's calling the yara.exe, so the executable that we have here, and giving as a parameter the Yara rules path, so our Yara rules that we will check later. and the file in question, the one that we would like to check whether it is malicious or not, and then we will get as input, we will redirect the result from the Yara tool to a file that I have called res as result.alta. Okay, so we have here once the process has finished, so we can exit this function here. Alright, and once this is done, so if I go back to the reference where I have called this, so if you can see here, we have called this function in the two thread files and also folders. So I can go back to whether any of them, and we can see here the post scan. So if I go to the post scan, so it's this function or procedure will be called after the previous one. So here what we are doing, actually we are just reading the file that we have created in the previous call, so the res result.alta, and we are checking whether this file is empty or not. So if it's empty, this means that our file is healthy, it's not malicious. Okay, so first we are showing all the lines inside, and if not, so here we are checking if the file has some content or not. So here, if it's empty, so we say that the file is clean. If not, we do this. So what we are doing here, actually, we are moving the file in question to the quarantine folder. Okay, we are putting here, we are adding an extension as .mal, and here in this instruction we are checking whether maybe the file is already with the same name, it's already in the quarantine folder. So if it's the case, we have just adding here as a prefix the timestamp. Okay, this is the function where we're moving to the quarantine. Alright, so now we can check the error rules. So this is the core actually of this tool, so where the magic happens. As you can see here, in here we are using two modules, so we have PE and we have math, so we will need some mathematic functions. Alright, so we have many functions here. The first one is to check whether the file is PE. What does mean PE? PE, it means that the file is executable. So whether it's .exe or .dll and some other formats. So here we check, how do we know if it's executable? So Microsoft is putting in the a signature in the file to check whether it's a PE or not. So there are two ways to know this, and both of these actually two conditions, and both of these conditions must be true. So the first one, that in the address 0, so the first couple of bytes in the file, they must be referring to this value, which is means MZ. So MZ is the from the name of the person who created this concept. And the second condition, it's that at this exact address we need to have this value, which means PE. So if this condition is true, it means our file is executable. Okay, next function here, we have a function to check whether the file is has malicious strings, as you can see here. So among the strings, whether there is a command to launch a new task, or actually to create scheduled tasks. So here we need to raise a warning that maybe this is malicious. We have also running PowerShell scripts or any JavaScript scripts. Okay, here also it's quite malicious, is to run in external DLL. So this is here we need to raise the flag also to the user. to warn them. Okay, here we have I don't want to go through the syntax of Yara, but here it means that any of them, so it means that all these rules or actually if one of these rules is true, so we need to raise this flag. Okay, next, so here to check whether the file is or can be a ransomware. So ransomware is a file or is a malicious malware that you install accidentally, or it can be injected to your files, and which is encrypting all your files and asking for a ransom to be paid, so an amount of money to be paid if you would like to get back your files. Right, so here's some strings that help us to detect whether the file in question is ransom or can be a ransomware. And here the condition that we raise this flag is, first we need that this file has to be executable, because obviously you cannot have a ransomware or a malware. Most of cases, actually, I can't say obviously, but in the most of cases it has to be executable, so whether .exe or a DLL file. And the second condition, that if 4 of these conditions are true, this means that we raise the flag. Okay, so it means if we have these 4, that it means that if we have a file which contains these 4 strings, we raise the flag, or 2 here and 2 in the end. Okay, so 4 among these. The second function is to check whether the file is, or the program in question is injected. So this means that there is really advanced methods which can inject a file. So we have a file which is clean and healthy, like you can imagine as a calculator or any other file, commercial well-known file. And what some guys are doing is injecting this file with a malicious one. So in this case we have one healthy file, so .exe file, and we have a malicious file which is exe also. So the idea here, that if you check this file, if you analyze it, you will find that it has 2 MZ signatures. Okay, so it has twice this sentence in the file itself, in the executable, and for sure here it has to be also a PE file. Okay, and here whether to check if the file is packed. So this is a common way. I would say that 99% of the malicious or malware are always packed. This is for 2 reasons. The first one is to reduce the size of the file, because it needs to, their goal is to infect as many people as possible, so it needs to be a small file to go through the network. And the second reason obviously is to mislead the antivirus. Okay, so here to check whether the file is packed or not, so we have something called the entropy. So in mathematics, the entropy means if the file is kind of compressed, or so in this case it means that it's encrypted. So here we are checking if the file, so the whole file, so from 0 until the size, so it means the whole file entropy is equals or greater than 7. This means that the file is packed, so we need to raise this flag. Or if not, the whole file is packed, then there are some sections. So the PE file contains sections. So here in this loop here, we go through the sections and we check whether one of the sections is packed, so the entropy equal or greater than 7, so this instruction which we have here. Or also we check, there are some famous packers. One of them is called UPX. So this packer, after packing the file, it's renaming one of the section to UPX something. So here we are checking if the section, one of the section has this UPX. We raise the flag also, and we have some things that we need to check also that help us to decide whether the file is packed or not. For instance, here there is a section called characteristics. So these characteristics, if it's flagged as executable, so this means that during the runtime of the program, this section will be injected to another external file and it will be executed. So here we raise a flag also that it's packed. Okay, so in my code I have some comments here, feel free to check them. I have this code source in my GitHub. Okay, we have here another function to check the import table, also to assess whether the file is packed or not. So there are some functions, some famous, well-known functions that are used for packing and unpacking the file. For instance, we have here load library. We have here get the process address and virtual protect. So these functions actually are injecting the .dll file to an executable file. So we need to raise a flag also about this behavior. Okay, and we have here a bunch of malicious functions that we need to raise a flag whenever we face one of them. We have, for instance, the famous one in the malware world is debugger present. So here it means malware creators, they don't really like that we analyze their program. So when you say analyze, it means that there is a debugger behind, which is interrupting every and each instruction and trying to understand what the malware is doing. So what the malware authors are doing, they are checking if you are running a debugger. So if you are running a debugger, the malware won't work. It's just exit. So here, this is the we need to be careful about this also. So whenever there's a program which is checking that you are running a debugger, so it's suspicious. Okay, so the same for check remote debugger present also, and dbg breakpoint. So these are doing the same work. They are from different libraries. Okay, so the idea is to check whether the debugger is present or not. Some suspicious functions here. We have adjust token privilege, attach thread input, create remote thread, etc. So this is most of them are for DLL injection. Okay, and most of them, they are in this kernel library, so the kernel 32 DLL library. Alright, we have here some networking functions here. So this is to check whether some programs are spying on the user, are doing some HTTP or TCP, UDP communication, so as such this function accept and bind. Okay, so we need to raise also a flag and to inform the user that this is happening. There's some this is interesting function here, set file time. This is changing the file's time. And WannaCry virus or worm is doing the same. While I have been analyzing the WannaCry, I found that it's changing the file system time, and this is because of to mislead the user. Actually, it's changing the its own file time. So this is why, because if you go and you search the last modified the files or something, you will not be able to spot these files. Okay, we have some function here for the hook functions. So hook functions are for also injection, code injection or DLL injection. Here same for injection. You will see here a function also for encrypting, so like in the case of the ransomware. Alright, we have really some dangerous functions here like anti-race hard error, which is causing the blue screen of death. And we need for sure to inform the user about existence of such functions in the programming question. Alright, so that was it. We went through the code of this tool, and as I said, you can find it in the GitHub. You can feel free to just clone the code and you can go through it, modify it as you like, as you wish. Thank you for watching, and I wish you a good day. Bye.